This is called as breadboard. You can see there are 4 layers, 1, 2, 3 and 4. The, the topmost and bottommost layers are called as ground layers. Generally it is not required. If there is a need, then only we will go for this. But in general we will use the middle 2 layers, that is second layer and third layer, for giving the components connection. As you can see, there are certain holes which are available in these 4 layers. In the middle 2 layers, the current will try to flow in the vertical manner. That means we have to give the connections in the vertical manner. In the top layer and bottom layer, we have to give connections in the horizontal manner. So that is the basic difference that you have to understand. So in the middle 2 layers, that is in the second layer and third layer, the current will flow in the vertical manner. That's why we have to provide connection in the vertical manner. For example, if I want to connect any 2 components, that we will try to provide that connections in this middle layers, either with respect to second layer or with respect to third layer. This is the purpose of a breadboard. This is called as a breadboard. These are your connecting wires. These are your connecting wires. Connecting wires helps us to connect different components on the breadboard. Different components on the breadboard like resistor, inductor, capacitor, function generator, CRO probe, etc. So we can connect all those things with the help of these connecting wires. This is called as decayed inductance box. This is called decayed inductance box. As you can see here, decayed inductance box. Here I can vary the value of inductance from 1 Henry to 10.11 Henry. So that is the maximum range. As you can see, each knob is having 10 divisions. Each knob is having 10 divisions. So 10 into 1 is how much, Nana? It is 10 Henry. So here it is 10 into 100. So it is 1 Henry. So 10 Henry plus 1 Henry plus 0.1 Henry plus 0.01 Henry plus 0.01 Henry. So it will be 11.1111 Henry. So that is the total capacity of this decayed inductance box. Decayed inductance box. So in our transient response of RL series circuit, we require 1 Henry. As you can see, the knob is pointing what, Nana? 0. 0 into 1 is nothing but what? 0 Henry. But what we require? We require the value of inductor to 1 Henry. That's why I am shifting the knob. Now you can see the knob is switched to 1. So 1 into 1 is how much, Nana? It is 1 Henry. So the inductor value is set to 1 Henry. This is the proper purpose of an inductance. Here it has 3 terminals: positive, negative and ground. Ground terminal is not required. So we have to consider only positive terminal and negative terminal. Red indicates positive, black indicates negative. This is for our convenience, for easiest connection. We consider red as positive, black as negative. Okay. This is called as a capacitor. The value of this capacitor is 0.1 microfarad. It has 2 terminals. It has 2 terminals. Similarly, this is a resistor, Nana. This is called a band type resistor. This is called a band type resistor. I hope it is clear to you. It is visible to you. How many bands are there, Nana? It is having 5 bands. This is brown, black, brown, gold. Brown, black, brown, gold. These are your 5 colors. But out of these 5 colors, Nana, the last color which you are seeing, that is nothing but gold or silver at the end. Gold or silver at the end. That indicates the tolerance value. That we know that nothing is pure in nature. If I take human body also, it does not contain 100% of blood. It contains water and blood. So it contains some impurities. Here also, Nana, this gold color or silver color at the end indicates the tolerance value. That is, impurities may or may not exist. That is plus or minus 5%. Okay. So this is the value of 1 kilo ohm resistor. This is the value of 1 kilo ohm resistor. Brown, black, brown. In order to identify the value of this resistor, value of any resistor, we take the help of color coding. That is B.B. Roy, Great Britain, very good wife. Where first B indicates black, second one is brown, third one is red, orange, yellow, green, blue, violet, gray, white. So these are the color coding that which we have to use in order to identify the value of a resistor. For example, we have seen how many colors it is having, Nana? How many colors it is having? It is having 5 colors. First one is brown, black, brown, gold. Always the fifth color, it will be either gold or silver. Gold indicates plus or minus 5%. This is nothing but tolerance value. This is tolerance. Nothing is pure in nature. That's why we go with the tolerance. Generally, we consider ideal case, so we neglect this tolerance value. Plus or minus 5% or plus or minus 10%. Is it clear? So how many colors this band of resistor is having, Nana? It is having 5 colors. So always we have to start. So first one is brown, black, brown, and the last one is gold. Always we have to start our color coding exactly from the opposite end. So opposite end of the gold. Where is the gold color, Nana? To the extreme right. So we have to start our color coding from extreme left. So what is the first color, Nana? Brown. Second color, black. Third one, black. Fourth one is again brown. Now what is the code for brown from the color coding? What is the code for brown, Nana? 1. So we have to write here. What is the color for black? 0. What is the code for black? 0. When we come to the last color, we have to write in terms of power of 10. So what is the last color? Brown. What is the code for brown, Nana? 1. So last color, power of 10. So it is 100. It is 100 into 10 power 1, which is nothing but 100 into 10, which is 1000 ohms. Or I can write it as 1 kilo ohm. So based on this, I am telling that this is our 1 kilo ohm resistor. This is our 1 kilo ohm resistor. Is it clear, Nana? This is how you have to identify the value of a resistor with the help of color coding. It starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the color coding that we have to use.